In this lesson, I want to walk you through some practice in trying to write ionic formulas when you're given the name of an ionic compound. To do this, you really need to have a periodic table out. So why don't you hit pause and get your periodic table from your notebook or pull one up online and then hit play again. Okay, now that you have your periodic table out, let's go through, and what I have set up here is kind of a long form. My suggestion to students when you're learning how to do this is to include this step here, that eventually when you get good at this you won't have to write out anymore. But for now, it's important to remember that every ionic compound is made up of two parts. You have the cation and you have the anion. And for these binary ionic compounds, binary means two, there are only going to be two things in there. The first word in the name is the cation, the second word in the name is the anion. So what you need to do is take that first word, and this is example number one, it's aluminum, and you just need to write down what that ion is. So on your periodic table, find aluminum. It's in the P block, column 3A, or 13. It has 3 valence electrons, so we know then that aluminum is going to be +3. And then the anion is oxide. Well, go to your periodic table and find oxygen. Oxygen is in the P block, group 6A, or 16. It has 6 valence. And we know from the octet rule that oxygen wants to have 8, so it is closer to gain 2 and become -2. Now that you know what the ions are, you put them together. And we're going to put them together, and what we have to do is make sure that the ion charges add up to equal 0. Right now, +3 and -2 would not come together to equal 0. A couple of ways to do this. I think the most theoretically sound way to do it is to make this a least common multiple problem, like you learned to do in math years and years ago. Looking at 3 and 2, the least common multiple is going to be 6. So now I think to myself, how many 3's does it take to get to 6? Well, it takes 2 of them. And then for the oxygen, if it is -2, how many 2's does it take to get to 6? It takes 3 of them. There are different ways to approach this problem. Some people who are very visual might want to simply come out to the side and draw. Just keep adding ions. Now it's +3 and -4. It still doesn't work. So maybe you add another aluminum. So that's +6 and -4. It doesn't work. Add another oxygen, and you see that it works. That is another way to do it. A third way to do it is the one I despise the most. And I'm only going to show this in case you're struggling with the concept. And that is, if you write the ions kind of next to each other, a lot of the time, 50–60% of the time, you can do what we call a crisscross, and you swap the numbers. Again, I hate this method. It's kind of a wimpy way out, and it doesn't always work because sometimes your ions would then your subscripts would then have to be simplified. For example, I'm just throwing this one out there, iron and oxide. This is a case where the crisscross method would abandon you because you would get Fe2O2, and that's not correct. It's actually FeO when you simplify it. So the crisscross method is dangerous. I don't like it. I suggest you don't use it. It really works best in cases like our aluminum oxide, where you have one odd number and one even number. And all that's really doing is making the least common multiple game very easy. All right, so moving on. Problem number 2 is calcium chloride. So let's do the cation from your periodic table. Find calcium. It's an alkaline earth metal in group 2. So all of those will always be +2. The anion this time is chloride, so chlorine is a halogen, and the halogens are always -1. So now the least common multiple will be 2. Between 2 and 1 is always 2. So this formula is going to be CaCl2. If you're having trouble figuring out where I'm getting these ion charges from when I say look at your periodic table, you probably need to go ahead and hit stop now and come see me, and then you'll pick up on this lesson when you get that fixed. Iron 2 sulfide. Now the Roman numerals in ionic bonding cause a lot of heartburn for students. But going this way from a name to a formula, they make things super easy. Some students mistakenly think that the Roman numerals tell you what the subscript is. No, 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 no. They tell you what the charge is, what the oxidation number is. So I know then that that's iron, and the 2 tells me it's +2. Not Fe subscript 2, but Fe charge 2. And then the anion here is sulfide. Sulfide on the periodic table, find it, is in group 16, right under oxygen. So it is also going to be -2. Putting those two together is very easy now because you have a +2 and a -2. Those go right together. They cancel directly, so you get FeS. Notice that I am not putting charges in my final answer. Don't do that. When you put the two ions together, the charges cancel each other. Every compound here is neutral. The ions are charged, the compound is neutral. Number 4, copper 1 hydroxide. So the cation is going to be copper. The Roman numeral tells me it's +1. And now we have hydroxide. Hydroxide is a polyatomic ion. So you either have these memorized or you have a list handy. If you need to find your polyatomic ion list, hit pause and pull it out. Hopefully from your memory you know that hydroxide is OH with a -1 charge. So again, we have 2 ions of opposite charge. So the formula is going to be Cu and OH. Okay, I've skipped down here. I don't want to go through all these and bore you too much. But I do want to do number 7 here. Number 7, we have a cation, lead 4. So that's going to be Pb, and then the Roman numeral tells us +4. And the anion is nitrate. So from your list of polyatomic ions, you find nitrate, it's going to be NO3 -1. That was one of the polyatomic ions that we had to just memorize. I'm showing you this one because I want to look at what we have to do to write this formula. We have a +4 and a -1. The least common multiple there is going to be 4. So I'm only going to need 1 Pb. And then for the NO3s, I'm going to need 4 of them. So I have to be careful where I write this 4. I can't just put it out there because it looks like 34. When you have polyatomic ions and you need more than one, we have to use the parentheses to separate the subscripts. And make sure you put the entire polyatomic ion inside the parentheses. Let's just end this lesson up with some more typical practice, because most time you aren't going to have that blank there for cation, anion. Here's what I do, and I'm not ashamed to admit I do this even to this day. When I see a name like this, I write the ion under the first word. So the first word here, magnesium, I know that's going to be Mg. From your periodic table, Mg is an alkaline earth metal. It's going to be +2. Chlorate, this suffix tells me that's a polyatomic. So I go to my list, I find it, ClO3 -1. So now I'm actually looking at my 2 ions. So putting them together is fairly easy. The common multiple is going to be 2, so this is going to be Mg, and I'll need 2 of the chlorates. So MgClO3, 2. Why don't you do number 2 right now? Hit pause, and then we can check our answers. All right, let's see how you did. Ammonium perchlorate. Well, ammonium is a polyatomic ion, so from your list, NH4 plus, and then perchlorate, ClO4 negative. Both of those from my polyatomic ion list. Opposite charges, they're going to go right together. NH4, ClO4. No parentheses needed because I have 1 of each ion. All right, last one. Hit pause again and try number 3. Okay, let's see how you did. For barium permanganate, barium is a cation it's a monatomic cation. So for the periodic table, again, group 2, barium is +2. Permanganate, suffix tells me it's polyatomic if you're not sure. So go to your list and find permanganate. It is MnO4 -1. The least common multiple again is 2. So this is going to be Ba. I need 2 permanganates, so I'll use the parentheses, and then 2. All right, we're going to do a lot of practice on this in class, but if you have any immediate questions, come to see me before school.